Problem 16. The sum of the digits of number 2014 is 7. How many numbers between 100 and 1000 also have 7 as the sum of their digits? These are our options. We need to find 3-digit number from 100 to 1000 where the sum of the digits is 7. Let us first understand 3-digit number format. 3-digit number format has 100, 10 and 1. At the position of 100, we can have a digit 1 to 9. At 10, we can have 0 to 9. And at 1, 0 to 9. The sum of these digits, 100 place, 10 place and 1 place should be 7. And this is what our problem states. Since the sum of the digits must be exactly 7, we can eliminate any option where the digits adds up to more than 7. So we know the sum of the digits for 100 place should be 1 to 7, 10 should be 0 to 7, 0 at 1's place it should be 0 to 7. Now, as a second step, we find all the possible values of 100 place, 10 place and 1 place which adds up to 7. Let's count valid combinations. So we know 100 place, 10 place and 1's place should be 7. Consider 100 place to be 1. If 100 place is 1, then 10 place plus 1 place is equal to 6 because we subtract 1 from both sides and we get 6. So if we fix position 100 to 1, then the sum of these two places should be 6. So what are those numbers in a combination 2? We would have 0, 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, 1 and 6, 0. So considering if 100 place is 1, then there will be another number 0, 6. If we fix 1, then another number could be 1, 5 and their digit sum would be 7. Similarly, if we fix position 2 to 100 place, then the sum of this would be subtracting 2 from both sides, we would get 5. Then we should have the sum of those numbers should be 5. So 10 place and 1 place should be 5. 10 place and 1 place should be 5. So we found all the combination of these numbers and their possibility is 6 numbers. So taking an example, if we fix 100 place as 2, then the next number could be 10 place is 10 and 1's place is 5 and their sum is 7. This is the way we found it out 6 numbers. Similarly, if we fix 100 place as 3, then we could find the possibility 4 by subtracting 3 from both the sides. Then we get t plus o gives us 4. So we would have 4 as a sum of those numbers. We find this many possibilities. So these are 5 possibilities. Similarly, we try with 4. We find it 4 numbers and their sum is 3. With 5, we find this many possibilities. With 6, we find this many possibilities. And with 7, we found 1 number. So finally, we found all the combinations of the numbers whose sum is 7 between 100 and 1000. And we know with each combinations that how many possibilities are there. So we sum them and we find 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 gives us 28 numbers. So option is D, 28 numbers. Awesome. We cracked problem 16. Now let's keep up the momentum and dive into problem 17. Get ready for another fun challenge. Let's break it down step by step. Problem 17. Rabbit Boria likes cabbage and carrots very much. Each day, he eats either 9 carrots or 2 heads of cabbage or 1 head of cabbage and 4 carrots. Last week, Boria ate 30 carrots. How many heads of cabbage did he eat last week? These are our options. If Boria eat 9 carrots a day in a day for 7 days, then it would be 9 multiplied by 7 gives us 63. It's too many. So that's not possible. If he eats just the 2 heads of cabbage, then he's not eating carrots. That's not possible either. So Boria must have had some mix of carrots and cabbage. So we have to find how many days he ate cabbage head. Let's check. If he ate 1 cabbage head plus 4 carrots for some days, and we consider it as 3 days, that means he ate 3 cabbage and 3 multiplied by 4 gives 12 carrots. So he has 3 cabbage heads he ate. That leaves to 30 minus 12 carrots. That means 18 carrots left. If Boria ate 9 carrots on those days, then 18 divided by 9 gives us 2 days. So 2 days he just ate carrots. Now let's count the days. He has 3 days and 2 days, but we have 7 days in a week. So 5 days he ate 3 cabbage heads and 2 days he ate carrots. Then what was the remaining days he had? He has remaining 2 more days to eat. So 2 days he ate 2 cabbage heads. That means 2 multiplied by 2 gives 4 cabbage head. And this is total to 7 cabbage head. So finally our answer is he ate 7 cabbage head, which is our option B. That was fun, but can you handle the next one? Let's find out. Problem 18. 7 children are standing in a circle. No 2 boys are standing next to each other. No 3 girls are standing next to each other. How many girls are there standing in the circle? These are our options. Let's break down the problem step by step to figure out how many girls are in the circle. We have 7 children standing in a circle. No 2 boys can stand next to each other. No 3 girls can stand next to each other. So we need to figure out how many of the 7 children are girls. So let's figure out that this is a circle, and let's figure that G is for girl and B for boy we are using. Since no 2 boys can stand next to each other, there must be at least 1 girl between them. So we say boy here, we say boy here, we say boy, and no 2 can stand each other. So there is nothing. Now we represent it as a B, B, B. Now we see that there is a spot for girls, so we put it girls, G, G, G. Since no 3 girls are standing next to each other, that means 2 girls can stand to each other. So in total there are 1, 2, 3, 4 girls in the arrangement. So our answer is option C, only 4. Great job solving this problem. Keep practicing and soon you will be a math whiz. Keep up the awesome work. Now we are almost halfway and on to the problem 19. Problem 19. Eve arrange cards in a line as it is shown in the figure below. At each move, E is allowed to interchange any 2 cards. What is the smallest number of moves Eve needs to get the word kangaroo? This is the placement of the cards given to us, and these are our options. We need to rearrange the letter O, A, R, G, O, and K, A into the correct order kangaroo by swapping 2 cards at a time. So what we will do, we have this placement of the card given to us. We will compare it with kangaroo and then we swap. So initially we will start from the left side. So we compare K with O and we see that we need to rearrange it with O. So here we have going to arrange. So our first move is move 1. Now we move on to the second letter A. A is compared with A, nothing has to be done. Then we move on to the next letter R, and that is compared with N. We need N here, which is here below R, and we swap it. So it becomes N, and our move increases to 2. Then we have G, same, we won't do anything, we move further. We move to the next letter, O. Then we compare O with A, and here we have the last one, so we compare it. So our move changes to 3. So we did 3 moves to swap the placement of the cards to make it kangaroo, and our option is B, 3. Great job. You are mastering these challenges step by step. Keep up the great work and let's make the momentum going. Now let's move on to the next exciting problem, which is the last problem of this series, problem 20. Problem 20. The first 3 stages of a pattern are shown in the picture. How many black diamonds does the figure in stage 6 have? We have given the first 3 stages of a pattern. Our goal, find how many black diamonds increases as we move to stage 6. And these are our options. First, let's count the total diamond in each stage. So we have position 1st, 2nd, 3rd, 4th, 5th and 6th. Total diamonds at first, in the first diagram we have 3. In the second diagram we have 6. And in the third diagram, we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So do you see a pattern in it? Let's check the differences. 6 minus 3 gives us 3. 10 minus 6 gives us 4. The increase follows a pattern. Plus 3, plus 4. So what would be the next? It would be plus 5. So 10 plus 5 gives us 15. 15 plus 6 gives us 21. And 21 plus 7 gives us 28. White diamonds. So white diamonds are 2 in each stages. So we marked it as 2. So what is the black diamond now? Difference between total diamond and the white diamond gives us the black diamond. So 3 minus 2 gives us 1 and this is 1. We have 6 minus 2 gives us 4. We can see 4. 10 minus 2 gives us 8 and we have 8 black diamonds. 15 minus 2 gives us 13. 21 minus 2 gives us 19 and 28 minus 2 gives us 26. So at stage 6 we have 26 black diamonds. That means the correct answer is option C, 26. Awesome work. You have tackled all the problems like a true champion. This wraps up our challenge for today, but don't go anywhere. There is much more fun and exciting math coming your way. And we will be tackling problem 21 to 24. Make sure to like, subscribe and hit the bell so you never miss a new challenge. See you in the next problem solving adventure. Thank you.